Hello tutors, welcome to this week's training blog video. This is Sister Ashcraft. We've had a couple of students give feedback that our tutors are those struggling a little bit with compound inequalities. So I want to do some reminders here in this week's training video. Before I do, I want to show off a little bit. Some of you know that I am currently taking my very first coding class, exciting. And these statements that have the word and or are actually really important for logical statements in coding. I want to show you some things to help make this make sense. So here we are in Visual Studio Code using Python. And so I have some statements set up with X's and Y's or with A's and B's. And so if our first statement is true that X is less than 10 and Y is greater than 2, then the computer will show us that brother O is awesome, which we all know is true. And then I have another statement that if A is less than 10 or B is greater than 2, it'll tell you how cool I am. Sister Ashcraft is cool. All true things, right? So let's go ahead and see how this works with the numbers 6 and 7, just to show you how it works. Okay, I printed both statements because they are both true. So I have brother O is awesome and Sister Ashcraft is cool. But if I come in and change the second variable, the one that's supposed to be greater than 2, to being a 1 instead, let's see what happens. Let's first clear this out and see what happens. It didn't tell us anything about brother O. And you'll notice the difference between our two statements is this word and. And in my statement, it says the word or. So for an and statement, in order for it to print the conclusion that brother O is awesome, both statements have to be true, which in this case it is not because y equals 1. For an or statement, either one can be true and it will run the program. Right? It will say that Sister Ashcraft is cool. So for an and, we're looking for where both statements are true. And for an or statement, we're looking for where one of them is true. It doesn't matter. Just one of them has to be true. Okay, let's apply this to Math 101, some intermediate algebra. Coming back here. So just a reminder, and is where both statements are true. And an or is when either statement is true. It doesn't have to be both of them. It could just be one of them. So I always tell my students, look for an overlap for ands. And to just draw a picture. I have to visualize it. It helps them to visualize it. And so we're going to draw it on a number line. So I'm going to start with X is less than 1, greater than or equal to negative 3. Okay. So we're going to look for where both statements are true. So that's numbers like negative 2, 0.7. So they're between negative 3 and 1. And we say that by making this line. And, ooh, I need a parenthesis. Sorry. I need a parenthesis after that 1. My bad. But it's just between those two where they overlap, from negative 3 to 1. There it is, an interval notation. And then I'm looking at the second one, X is less than or equal to negative 1, and X is less than 1. So the space between negative 1 and 1 is not going to work because not both statements are true. I'm looking for where they overlap. So I just need from negative infinity to negative 1, and I stop it there. So I just have to say that X is less than or equal to negative 1. I don't have to say the whole statement. It's redundant to say both. So I just say from X is less than or equal to negative 1. Now in this one, we actually have two that are going opposite directions from negative 3 and 2. And so there is no place that they overlap. There is actually no solution. There's no way to put on a number line. Our answer is that there's no answer because there's nowhere that is both less than or equal to negative 3 and greater than or equal to positive 2. This doesn't work. However, if it was an or statement, here we are now looking at the ors, and it can be true in either or both, right? So we're looking for our or inequalities. So numbers that are less than or equal to negative 3 or greater than or equal to 2. So this is how we would write it in interval notation. We take both, right? From negative infinity to negative 3, and then our union symbol, meaning or, and then from 2 to positive infinity. And again, we're looking at another or statement now. We're looking at X is less than 0 or X is less than 2. So we're going to take the overlap, but we're also going to take that space between 0 and 2 because it's going to work for all of them. And so it's going to say X is less than 2. So our answer is actually just negative infinity to 2, or just X is less than 2. Again, it's redundant to also say the 0 part. Let's look at one last one. We have X is greater than 0, or X is less than 4. Notice that's covering everything, right? And we don't care where they overlap, just as long as one of them or both are true. And So this is actually infinite solutions, from negative infinity all the way to positive infinity. Hopefully that helped you to understand these compound inequalities in some unique cases. Good luck! Thank you, tutors.